Hello students, today we are going to discuss one more program related with method recursion. And the question is, write a Java program to find and display the highest common factor, okay, or you can say GCD, greatest common divisor. Both are same, okay, highest common factor and greatest common divisor, both are same thing. Clear, na? So write a Java program to find and display the HCF, or you can say GCD of two integer numbers. Use the method recursion technique. Okay. Now listen, first of all, let me tell you what is the way of finding HCF of two numbers. Okay. See, if N1, that is the first number, is 96, and if the second number is 54, okay, let us take 54, 96 and 54. Yes, 96 and 54. Now, see, which is the greater number? 96 is the greater number. So what I will do, I will take the greater number as dividend, okay? And which number is the smaller one? 54 is the smaller one. So I will take 54 as the divisor, okay? Now let me divide 96 by 54. So 54 2s are 108, which will be larger than 96. So I will take 1. 54 1s are 54. Okay, 6 minus 4, it is 2. And 9 minus 5, it is 4, 42. Now, the remainder is 42, which is not equal to 0. If it is not equal to 0, we will have to go to the next step where the remainder will become the divisor and the previous divisor will become the dividend. That is, 54 was the previous divisor. In second case, it will become the dividend. And 42 was the remainder, it will become the divisor. So 42 2s are 84, which will be greater than 54. So I will take 42 1s are 42. Okay, so 4 minus 2, it is 2. And 5 minus 4, it is 1. Now the remainder which we are getting is 12. 12 is not equal to 0. So in the third step, this remainder 12 will become the divisor, and the just previous divisor, that is 42, will become the dividend in the third case or third step. Now 12 4s are 48, which is larger than 42. So we will take 12 3s are 36. Okay, 12 minus 6, it is 6, and 3 minus 3 is 0. Now the remainder is 6. It is not equal to 0. Since it is not equal to 0, so in the fourth step, this remainder 6 will become the divisor, and the just previous divisor, that is 12, will become the dividend, Okay. Now 6 2s are 12. 6 2s are 12. That is equal to 0. Remainder is 0. Now, we are getting the remainder 0 because of which divisor? Because of 54? No. Because of 42? No. Because of 12? No. Because of 6. Because of the divisor 6, we are getting the remainder 0. So 6 will be the highest common factor of what? 6 will be the highest common factor, or you can say greatest common divisor of which numbers? Of 54 and 96. Of 54 and 96. Now what we will do, we will take the variables, 3 variables. Okay, we will take 3 variables, int, dividend. The first variable will be dividend. Now in dividend, we need the larger value. Now how to get the larger value? So let me use the ternary operator. Okay, so if N1 is greater than N2, question mark, so N1, the value of N1 will be initialized to the variable dividend, or else the value of N2 will be initialized to the variable dividend. Clear? Then int divisor. Int divisor is equal to N1 less than n2, n1 less than n2. Okay, so if n1 is less than n2, the value of n1, that is a smaller value, will be initialized to the variable divisor, or else the value of n2 will be initialized to the variable divisor. So what we are doing, we are just assigning the greater value to the variable dividend, and we are assigning the smaller value to the variable divisor. Clear? Now what we will do, we will take another variable, that is remainder. Okay, so remainder is equal to what? Dividend modulus divisor. We will write int divisor is int remainder is equal to dividend modulus divisor. Dividend modulus divisor. Okay, because modulus operator is used to find the remainder. Okay, clear na? What is happening here? Listen. See, so in the first case, 96 is the dividend. Okay, 96 is the dividend and 54 is the divisor. Yes or no? And this 42 is the remainder. REM or remainder. Let us take REM only. Clear na? Now this remainder is not equal to 0. This remainder is not equal to 0. So this remainder will become the divisor. This remainder will become the divisor, and the previous divisor, that is 54, will become the dividend. Now this 12, okay, this 12 is the remainder. Since this remainder is not 0, so this 12 will become the divisor. Okay, and the previous divisor, that is 42, will become the dividend. Clear? Now the remainder is 6. Okay, clear? Now this 6 is not equal to 0. Thus 6 will become the divisor, and the previous divisor, that is 12, will become the dividend. It will become the dividend. Now this remainder is 0. Now the remainder is 0. Okay, the remainder is 0. If the remainder is 0, this is the base case. We are using the method recursion technique. What is method recursion technique? Method recursion is a process in which a method calls itself. Now, if we are going for the process of method recursion, we need to think about two things. We need to think about the base case, that is the terminating case, that is when the method will stop executing. And the second thing is we need to think about the recursion case or recursive case, where the execution of the method will continue, where the call to the method will continue. That is the recursive case. Now, what is the terminating case here? The terminating case is if remainder is equal to 0. Okay, so we need to return what? We need to return the divisor. Which divisor? That divisor because of which the remainder 0 came. So we will return the divisor. At that particular time, whatever will be the value of divisor, that value will be returned because the remainder is 0. Okay, so this is the base case within the recursive method. This is the base case, or you can say terminating case. Terminating case. Clear? Now, what about the recursive case? Else return what? See, initially the divisor was 54 and the dividend was 96 and the remainder was 42. Yes or no? So remainder is equal to 0? No. So we need to call the method again. Now assume The task of finding the HCF is given to a method with name get HCF. Get HCF. Now in the first step, the remainder is 42, which is not equal to 0. So the else part will be executed. In the else part, we need to pass two values. We need to pass two values. Now what will be the first value? The first value will be the divisor, okay, for the second step. Now what is the divisor? You can see the divisor is the remainder, which is obtained at the very first step. Clear na? So we will pass the remainder. We will pass the remainder, and second we will pass what? 54. What is 54? 54 is the previous divisor. 54 is the previous divisor. Now when this remainder will go to n1 and divisor will go to n2, then again the dividend and divisor value will change. Clear? Now let me clarify this one. Just give me some time. I will explain. Don't worry. Huh? Listen. See, public static int get HCF. Public static int get HCF int n1 int n2. Okay. Now within this method, I will decide the dividend divisor. Okay, dividend and divisor. So what is the dividend? What should be the dividend? The larger value should be the dividend. So how to get the larger value? Let me use the ternary operator. If n1 is greater than n2, so n1 will be initialized to the variable dividend, or else n2 will be initialized to the variable dividend. Clear? Now int divisor. Int divisor is equal to, so the smaller value, how to get the smaller value? n1 less than n2. So n1 will be initialized to the divisor, or else n2 will be initialized to the divisor. Okay. Now let me calculate the remainder and store in the variable remainder. Remainder is equal to dividend modulus divisor. Dividend modulus divisor. Clear? Dividend modulus divisor. Now what is the base case? The base case is if remainder is equal to if remainder is equal to 0, so we will return the divisor. We will return the divisor. Now why? Listen, let me write it once again. See, 96 and 54. Okay, 96 and 54. So 54 ones are 54, 2, 4, 42. Okay, now listen. In this case, assume the value of n1 is what? 54, and the value of n2 is 96. Now, 54 is greater than 96, false. If it is false, the value of n2 will get initialized to dividend. So the dividend value will be n2. n2's value is 96. So the greater value is initialized to the variable dividend. Okay. Now n1 less than n2. What is n1? 54. 54 is less than 96. Yes. If yes, the value of n1 will be initialized to the variable divisor. So the divisor value will be n1. What is the value of n1? 54. Clear? Now here we have written dividend modulus divisor. So what is dividend? 96. 96 is the dividend. 96 is the dividend and 54 is the divisor. 54 is the divisor. Clear? Now, what is the remainder? The remainder is 42. Okay, remainder is 42. Is it equal to 0? No, it is not equal to 0. Okay, it is not equal to 0. So, return, no, not return, else part. Else return, else return what? Now we need to continue the same method of dividing the dividend by the divisor. Now in the second step, okay, the remainder will become the what? The remainder will become the divisor. The remainder will become the divisor, and the previous divisor 54, okay, it will become the dividend. It will become the dividend. Yes or no? Yes. So return, we will call the same method get HCF, but now to n1 parameter, we will pass the remainder value because remainder is not equal to 0. And in this case, the remainder is 42. Now, so we are passing 42. So this remainder value will go to n1. Okay, remainder value will go to n1, and we need to pass 54. Now 54 is available where? 54 as of now, 54 is available in divisor. Yes or no? So we will pass divisor. So the remainder will become the divisor and the previous divisor will become the dividend. Clear? Now this process will continue. This process will continue. Clear? Okay. Now let me show you how this method is working. See, what is the highest common factor of 2 and 3? So 2 and 3, highest common factor, or 3 and 6. Yes, 3 and 6. Assume 3 and 6. So 3 and 6. So 3 2s are 6, remainder 0. Now let me give you some example where at least 2 steps are there. So what could be the example? 42 and 8. Yes, let us take the example 42 and 8. Okay, let us take the example 42 and 8. Okay, 8. So since 8 is the smaller value, it becomes the divisor, and 42 is the greater value, it becomes the dividend. Okay, 8 5s are 40. Clear na? 8 5s are 40, remainder 2. Now since it is not 0, so the previous divisor 8 will become the dividend in the second step. So 2 4s are 8. Now the remainder is 0. Now the remainder 0 is obtained because of which divisor? Because of 2, not because of 8. So 2 is the highest common factor, you can say greatest common divisor of 8 and 42. Of 8 and 42. Clear na? Okay. Now let me call the method. Okay, listen. Listen. So what is the method? The method is public static int get HCF and two parameters n1 and then int n2. Int n2. Okay. Now what is the base case? If remainder is equal to 0. If remainder. For that we need to calculate the remainder. Now let me declare the variables int dividend. Dividend is equal to n1 greater than n2, n1 or else n2. Okay. Int divisor is equal to n1 less than n2, n1 or else n2. Int remainder. Int remainder is equal to dividend modulus divisor. Dividend modulus divisor. Okay, dividend modulus divisor. Now here you can check if a remainder. If remainder is equal to 0, the method has to return what? The divisor. The method has to return the divisor. Else return what? Get HCF. Get HCF and just pass the remainder since the remainder is not equal to 0. Okay. and the previous divisor so that the remainder can become the divisor and the previous divisor can become the dividend. Okay, clear? So let me show this to you. Assume the value of n1 is 8 and n2 is 42. Clear? Okay. Now n1 greater than n2. What is n1? 8 greater than 42? False. If it is false, the value of n2 will get initialized to dividend. So the value of dividend will be 42. Okay. Now n1 less than n2. What is n1? It is 8. 8 is less than 42. Yes. So the value of n1 will get initialized to divisor. So what is the value of divisor? The value of n1, that is 8. Clear? Clear na? So the dividend is 42 now and the divisor is 8. The divisor is 8. Now remainder. What is the remainder? Dividend modulus divisor. So 8 5s are 40. Remainder is 2. Remainder is 2. Okay. Now remainder is equal to 0? No. So else get HCF remainder. What is the remainder? The remainder is 2 and at this particular time the divisor value is 8. You can see at the right side, yes or no? Dividend is 42, divisor is 8 and remainder is 2. Since the remainder is not equal to 0, if the remainder was 0, the method would have returned the divisor, means 8. But since the remainder is not 0, though, so the else part will get executed. Okay. So in the else part we have returned get HCF. I mean we have called the same method. Now, while calling the same method, I have passed the value of remainder and the value of divisor. And what is the value of remainder? The value of remainder is 2 and the value of divisor is 8. Clear? Now let me write the same method. Okay, copy of the same method. Public static int get HCF. So this is the clone of the same method. This is the clone of the same method because we are going for the process of method recursion. Okay, int n1, int n2. Here also the same thing is written. Int dividend is equal to n1 greater than n2, n1 or else n2. Int divisor is equal to n1 less than n2, n1 or else n2. Int remainder is equal to dividend modulus divisor. Dividend modulus divisor. If remainder is equal to 0, if remainder is equal to 0, return divisor or else return again call the same method, get HCF method and pass the remainder value. Okay, the remainder value and the divisor value. Okay, now close the block of method, Now listen, what is happening? This value 2 is getting passed to n1, this value 8 is getting passed to n2. Clear na? Now n1 greater than n2, 2 is greater than 8, it is false. So the value of n2 will get initialized to dividend. So 8 will come to dividend. Now the dividend value is, what is the dividend value now? It is 8 and n1 less than n2. 2 is less than 8. Yes, it's true. So the value of n1 will go to divisor. Okay. So divisor is equal to n1. What is the value of n1? The value of n1 is 2 because 2 has come to the parameter n1. So it is 2. Okay. So the divisor value is 2. Now remainder is equal to dividend modulus divisor. Okay. Now remainder is equal to what? Remainder is equal to dividend modulus divisor, means 8 modulus 2. So the remainder is 0. Now here we are checking, is the remainder 0? Yes, it is 0. So return divisor. So what is the value of divisor? Just 1 minute. Yes. What is the value of divisor? The value of divisor here is 2. Okay. So 2, the value 2 will get returned. Where? Here. Okay. Here the value 2 will get returned. And from here, the value 2 will get returned. Okay. The value 2 will get returned. And see, 2 is the highest common factor of 8 and 42. Clear, na? So this is how the recursive method, that is get HCF method, is working. It is calling itself and it is making the task possible. Okay. Listen, let me type the same program for you. Give any name, double click, maximize the screen, Control A, backspace, import import java.util.scanner scanner. Okay. PUBLIC public CLASS class HCF finder. I repeat, HCF and GCD both are same. Highest common factor, or you can say greatest common divisor, both are same. Okay. HCF finder, PUBLIC public, STATIC static, void void main, capital S TRING string array space args. Okay, now here let me create the object of scanner. Scanner scene is equal to new scanner, and here let me write system.in. Okay, now let me give the message to the user, system.out.println, enter two integer values, int n1 is equal to scanner object dot next int. Okay, and int n2 is equal to scanner object dot next int. Clear? Now int HCF is equal to get HCF method and pass n1 and n2. Pass n1 and n2. Here display system.out.println highest common factor of concatenation sign n1, concatenation sign, and concatenation sign n2, concatenation sign is equal to concatenation sign HCF. Okay. Now here let me define the recursive method get HCF. PUBLIC public STATIC static int get HCF int n1 comma int n2. Okay, clear? Now here I will write int divid and dividend is equal to okay, let me do one thing. Okay, let me decide the dividend and divisor here only within the main method and check whether the program is working fine or not. Okay, let me write the program just similar to this, okay, or else you will be confused. Okay, let me write it here only. Int dividend is, then afterwards I will change it. Okay, you will get to know, don't worry. Int dividend is equal to n1 greater than n2. So n1 will be initialized to dividend, or else n2 will be initialized. Int divisor, divisor is equal to n1 less than n2. Okay, so n1 will get initialized to divisor or else n2. Okay, int remainder, remainder is equal to dividend, dividend dividend modulus divisor. Okay, now we will check if remainder, if remainder is equal to 0, return what? Return the divisor. because of which the remainder 0 came. Okay, else return, and here call the same method get HCF, but pass the remainder, because the remainder is going to be the divisor and the divisor is going to be the dividend, Okay, clear? Control Shift I, Control K, no syntax error. Close, right click, main method. Okay, now 42 and 8. Let me pass 42 and 8. You can see HCF of 42 and 8 is equal to 2. Now let me pass 54 and 96. 54, 96. So what should be the output? The output should be 6. See, HCF of 54 and 96 is equal to 6. Now let me make some modification here only. Suppose in place of N1, let me write DI, VI, DE and D, dividend, int dividend. Okay, and here int DI, VI, SOR, divisor. Now what I will do, I will cut these lines from here and I will paste it here. Okay, Control Shift I. Okay, and in place of dividend, let me write here greater value. Greater value is equal to N1 greater than N2, N1 or else N2. And here, let me write a smaller value. SMALLAR, smaller, VALUA. Okay, smaller value. Now, what I will do, in place of N1, I will pass greater value, GREATR, greater value. And in place of N2, let me write smaller value. Okay, smaller value. Okay, clear now? Now HCF of N1 and N2 is equal to HCF. Clear. Now what is happening? See, okay, see what is happening. We asked the user to enter two integer values. Okay, so the user has given two integer values, and the first value we have stored in N1 variable, and the second value we have stored in N2 variable. Now whatever is greater, how to check which one is greater? By using ternary operator. If N1 is greater than N2, so N1 will be initialized to the variable greater value, okay, or else N2 will be initialized. And how to get the smaller value? By using the ternary operator. See, the condition is if N1 is less than N2, so N1 will be initialized to the smaller value variable, and or else N2 will be initialized to the variable smaller value. So this is how we are getting the greater value and a smaller value out of N1 and N2. So whatever is greater, it is getting initialized to greater value, and whatever is smaller, it is getting initialized to a smaller value. Clear? And then while calling the get HCF method, we are passing the greater value, and see the value of greater value variable will be initialized to the variable dividend, and we need it. Yes or no? Initially we need it. The greater value should be dividend and the smaller value should be divisor. So this greater value will be passed to the variable dividend, I mean parameter dividend, and this smaller value will be passed to the parameter divisor. So automatically this dividend parameter will get the greater value and this divisor parameter will get the smaller value. Clear? Clear, no? Now, what we are doing, we are just finding the remainder. Remainder is equal to dividend modulus divisor, and then we are checking if the remainder is equal to 0. So we need to just return the divisor, because of that divisor only the remainder obtained is 0. Now, if the remainder is not 0, you can see this here, the remainder is 2. Since it is not 0, now 2, that is the remainder, will become the divisor. It will become the divisor. Since the remainder is becoming the divisor, now I need to pass like this. I need to pass DIVISOR. I need to pass the divisor first and then the remainder. Now you might be wondering why. See, because when you are calling the get HCF method and you are passing divisor, see the first parameter is dividend. So if the remainder is not equal to 0, so the else part will execute. And in the else part, when you are calling the get HCF method, if I am passing the divisor value first, so this divisor value will get initialized to the dividend variable. That means in other sense, we can say that the divisor will become the dividend in the second step, and the remainder will become the divisor in the second step. Is it clear? That is the reason why we need to pass the divisor first and then the remainder. Clear? Okay. Compile, no syntax error, close. Then right click, main method, okay. Enter two integer values. So what were the values? The values were 42 and 8. 42 and 8. You can see HCF of 42 and 8 is equal to 2. Now let me give another input. The other input was 54 and 96. 54 and 96. You can see HCF of 54 and 96 is equal to 6. Clear, na? So this is how the recursive method works. The recursive method get HCF works. Clear? Clear or not? Okay. So you can take the screenshot. Take the screenshot of this. Take the screenshot of this. Okay. And see, this is the program. Okay. This is the program. You can take the screenshot of this. Take it. Okay. Now take the screenshot of this also. Clear? Okay. So thank you so much. Bye-bye. Take care.